Okay, so welcome to trig. The first thing we need to do is we need to make sure your calculator is in degree mode. So just like Fahrenheit and Celsius are two different measurements, degrees and radians are two different measurements. So in this class, we're going to be using degrees. If you'd like to pause your video now, you need to find your mode button and make sure degrees is highlighted. Okay, so again, if you'd like to pause the video now and do that. When you type sine 25 in your calculator, you should be getting approximately 0.4226. Okay, so if you're doing this correctly, again, try the cosine button, then hit 25. You should be getting approximately 0.9063. And then we have the tangent button, so tangent of 58. And you should be getting 1.6003. Okay, I also want to test and make sure you guys can do the inverse. Okay, so on your calculator, above the sine button, so you guys should have the sine button like this. Above the sine button, you should see sine -1. If you're using your phone, again, you should see sine -1 somewhere. In order for you to use this inverse sine button, you have to be able to use the second button. So you would hit second sine, and that's the inverse sine button. And then if you want, you can type in there like 2/3. Okay, so again, I'm taking inverse sine of 2/3. And I'm going to tell you approximately, I should say, what that is. So I'm hitting second sine 2/3. Okay, and I'm getting approximately 41.81 degrees. And again, I know you guys don't know what this is yet. I should put this in blue, 41.81. But we will be getting there, okay? The important thing right now is just making sure you guys can type these things into your calculator. If you can't, again, pause now and make sure you guys are able to. Okay, I'll go ahead and do a cos -1 of 1/2. Tell you what that approximately is. So cos -1, second cosine, 1/2 or 0.5, and that comes out to be 60 degrees. Okay, so, and again, I know you don't know what this is, but just making sure you guys can do this in your calculator. Okay, the next part of this is actually using our sine, cosine, tangent buttons. So we've been just kind of roughly, what's the sine, what's the cosine, what's the tangent? We now need to figure out if we're using sine, cosine, or tangent. Okay, so we're not going to be using the same one every single time. We have to figure out which one we're using. To do that, we have to analyze which two sides we are working with. Now, keep in mind that when we're working with trig, we're using a combination. Of course, we have a right triangle, and we're using a combination of an angle and two sides. Okay, so we need to analyze these two sides and take a look at if they are the opposite, the adjacent, or the hypotenuse, and that's going to tell us if we're using sine, cosine, or tangent. So I'm highlighting my reference angle, and I'm going to label my sides. I always start with the opposite side, so that's my opposite leg, I should say. My next side that I label is always the hypotenuse. Okay, and then of course we have our adjacent leg. Now in this case, we don't have any information about our adjacent leg, so I'll be working with the opposite side and the hypotenuse. Okay, and if I'm working with the opposite and hypotenuse, if you remember toa, because I'm working with the opposite side and hypotenuse, I will be using the sine. Okay, that tells me, so I'll set up my equation. The sine of 52 is equal to, so the sine of the angle is always equal to the opposite side over the hypotenuse. Okay, technically, guys, this is my proportion, right? Sine of 52 over 1. And according to the means extremes product theorem, I'm allowed to flip the numerator and denominator Okay, means extremes product theorem. So my new equation becomes x equals 10 divided by the sine of 52. So this is called an exact answer. If they asked you for the exact answer, this would be it. If they asked you for the approximate answer, I would type that into my calculator. 10 divided by the sine of 52. I'm getting approximately 12.69. And again, that is a side length. That's telling me that the hypotenuse is approximately 12.69 units long, inches, feet, whatever it is. Okay? Let's do this next problem. So you can see with this one, they're not telling me the angle. So I actually have to go through and I have to figure this angle out. Again, I'm working with a right triangle. I'm putting this up here, right triangle, and it's dealing with an angle and two sides. Trig, okay, that's what trig is. It has to do with an angle and two sides. So I'm highlighting the reference angle that I'm going to be using, and I will go ahead and label my sides. Again, I always start with the opposite side. So here's my opposite side. The next side I always label as my hypotenuse, and then I have my adjacent leg. Okay. With this one, I'm not working with the opposite side at all. Because I'm working with the adjacent and the hypotenuse, I will be using the cosine. So the cosine of the angle, in this case they used theta. Okay, so this little symbol, if you guys haven't seen this up until this point, this is called theta. Okay, represents an angle measure, an unknown angle measure. So the cosine of theta is equal to the adjacent side over the hypotenuse. Now instinctually, we want to solve for that theta. So instinctually, you guys want to what? Divide by cosine, divide by cosine? You cannot do that. That's like dividing by a square root. Okay, you can't do that. So in order to solve this, we actually have to take the inverse cosine of this side. And of course, if I do it to the left side, I have to do the inverse cosine of the right side. This cosine and inverse cosine cancel out, and I'm left with theta equals inverse cosine 15 over 17. Okay, in my calculator, I have to hit second cosine 15 over 17. And when I get that, I get theta is equal to 28.07. And again, that's approximate, and that's a degree. Okay, this is my exact answer right here, and this is my approximate answer. Exact answer and approximate answer. Okay. Next thing we have to know is angle of elevation versus angle of depression. So P, I always look at P like a person. So if a person is standing right here, looking up right here, that is called your angle of elevation. I'm standing on the ground and I'm looking up at this flagpole right here, so my head has to elevate. It has to go up. If a person is standing here, okay, and their head has to look down, let's say at a boat floating in the water, that is called angle of depression. Now, because we've worked with parallel lines, right, we can use our Zorro angles. So if you know that this angle of depression is 52 degrees, you also know that this angle right here is 52 degrees. Okay, so when we're working with our right triangles. So again, depression is your head is going down in the picture, and elevation means your head is going up to look at something. So if we analyze this word problem, from a point 12 feet from the base of a tower, so here's a point 12 feet from the base of a tower. There we go. There's a point 12 feet from the base of the tower. The angle of elevation to the top of the tower is 68 degrees. Angle of elevation means you're looking up to the top of the tower. Okay, so let's pretend this is the top. And that is 68 degrees, the angle of elevation. You have to elevate your head 68 degrees to look at the top of the tower. Find the height of the tower, x. Okay, again, we're mixing, we have a right triangle. We're mixing angles with two sides. So we're going to be using trig. So I have this angle right here. And from this reference angle, I'm going to label my sides. So this is my opposite side. This is my hypotenuse, and this is my adjacent side. I'm not using my hypotenuse at all. I'm only focused on these two sides, opposite and adjacent. Because I'm working with opposite and adjacent, that means I'm working with tangent, okay? So the tangent of the angle is equal to the opposite side over the adjacent side. To solve this problem, I would multiply by 12 and multiply by 12, and that's your exact answer, 12 times the tangent of 68. Okay, this is called your exact answer. If they asked you for the approximate answer, 12 times the tangent of 68, I'm just typing in my calculator, and I have x is approximately 29.70. We always round it to the nearest hundredth, and this is in feet, so I would label this feet. So my tower is about 30 feet tall. Okay, so always round it to 2 decimal places to the nearest hundredth. Below, I'm going to show you guys some more examples. So if you guys feel good and you want to start your homework, go ahead. If not, here's some more examples. So again, I'm looking at a right triangle, okay? Hypothetically, again, if this was 3, this was 5, and I'm looking for this, x right here, I would use Pythagorean's theorem, okay? 3 squared plus 5 squared equals x squared. 9 plus 25 equals x squared. 34 equals x squared, and the square root of 34 equals x, okay? But what if I am looking for this angle right here? This is where trig comes in. So again, what we're doing is we're using the ratio of the two sides that they're giving me. We're using the ratio of these two sides to determine this angle. That's what trig is. Okay, so again, I'm going to label my sides. So this is my opposite. This is my hypotenuse, which I don't care about right now. And this is my adjacent leg. So because I'm working with opposite and adjacent, I'm working with tangent. So the tangent of theta is equal to the opposite side over the adjacent side, okay? You immediately, because you're finding an angle, should know that you're using inverse tangent. Okay, so tan -1, 3 over 5, and you should have theta is equal to 30.96 degrees. You're finding an angle measure, okay? Exact answer, exact estimate. Okay, exact and estimate. But you're finding an angle measure, okay? Let's do another one. So again, you're given a right triangle. As soon as you see a right triangle, you know you can be using trig, you can be using Pythagorean's theorem, could be a 45, 45, 90, so you really have to analyze this. So let's say, for example, they tell you that this angle right here is 22 degrees, my lucky number. I don't know, we'll say that this side right here is x, and this side is 10. So I'm analyzing my drawing right here. I see that I have a right triangle. It's mixing angles and sides, so I know I'm using trig, okay? I can't use Pythagorean's theorem because I don't have two side lengths. So what I do is I highlight my reference angle. Again, I label the sides. Here's my opposite side. Here's my hypotenuse. And here's my adjacent side, which again, I'm not using in this one. Because I'm working with opposite and hypotenuse, I know that I'll be working with sine. So the sine of the angle is equal to the opposite side over the hypotenuse. Multiply by 10, multiply by 10. X is equal to 10 times the sine of 22. That's the exact answer. If they asked you for the estimate, I would say that my answer is 3.75, approximately. So this side length right here would be about 3.75. Okay? Again, you're using those two sides to determine if you're using sine, cosine, or tangent.